All right, welcome everybody. Today we're going to talk about two parts of of Unit 1, and that is 1.2 geographic data, and then 1.3 the power of that data. So let's go ahead and get into it. Remember, make sure you've downloaded and opened up a copy of the notes that go along with this, so you can take notes as we go. So here we go. So topic 1.2, so geographic data. Here's some of the stuff that we'll be doing, looking at how they gather data, especially down here. And where that information can come from. Alrighty, so let's go ahead and get started. So geospatial data, and we've used this term geospatial a fair amount already. And so geospatial data is data about anything so an object, an event, any kind of phenomena that is happening on Earth. It has a location on Earth. And so if it's something that's happening on Earth in space and time, then geospatial data exists for it. Now, that data could be static, and so static there. And so static data would be data that doesn't move. And so if you looked at where UHS is, the location of UHS, that would be static data. All right. And then we could have dynamic data. There's another thing. So dynamic data down here, that is data that is moving. And so if you've ever driven in your car with Google Maps on or another kind of map device, you can track yourself move. That would be dynamic data. Alrighty, and so geospatial data combines a few things. It combines your location, which is here. It combines attribute information. So what are the characteristics of the thing that you're measuring? And it could have this thing called temporal information, the time or the lifespan that something exists. And so thinking about something like COVID, that would be temporal data. When does it show up and when does it leave? Things like that. Alrighty. And so here's some examples of geospatial data. And these are just some basic maps. Any of the maps we've looked at really are geospatial data as well. So largest ancestry groups in the U.S. by county. And so this is showing us where those ancestral groups are from. Here's the school districts in Tucson. So here we are, Tucson Unified. And so there's the other school districts there. And so again, that's a static data, unless they decide to change the lines. County poverty rates in the U.S., again, it's geospatial data. It's measuring attributes of people. And then this is the Pacific Crest Trail. This is, if you're not familiar with it, this is the trail that goes from the bottom of California to the top of Washington State. Beautiful, beautiful scenery. Haven't done it. It's on the list, but so anyway, so this is the Pacific Crest Trail, a map of that. So all of those are examples of geospatial data. This would be another one. This is tweets and the language that those tweets are in. You can see down here, something like 400 million almost tweets. And so you can see just, around the globe, all the different, it's color coded. Again, that's a choropleth map because it's based on color. And so here, obviously, blue is English, green would be Spanish. Here's a little bit of French. There's some French, and so you get the idea. But again, this is just time and space data, geospatial data. So a couple of different ways to measure geospatial data to collect the information. One is called field work. And so field work is when people actually get out and go and collect the data themselves. It's not necessarily reliant on a computer to take measurements or anything. This is when people get out and take measurements. So it could be a census of the population, could be land survey if you go out and survey the land. Photographs, sketches, could be a lot of different things. But this is field work is when scientists or other folks get out and actually go do the measurements themselves. All right, another tool, which I'm sure you're familiar with, is GPS, Global Positioning System is what it stands for. And so we've got all these satellites orbiting Earth, and so they're able to triangulate on a location, so that gives us exactly where we're at. If you've used Google Maps or another map thing, that's GPS, all right? And so the biggest benefit, one of the biggest uses for it is obviously navigation. I use it to navigate a city I'm not familiar with. Airplanes use it, ships use it, It's a big deal. And so another use for it is to precisely locate borders. And so now we can actually pinpoint exactly where those borders are. We can map lines like a trail or fire hydrants in a city. So if we need to know the exact location of something, then we can use GPS. And so I showed you in the last class the GPS coordinates for UHS. All right, and so that would be the coordinates for UHS, and that was using GPS. All right, another way that they can measure for geospatial data is this thing called remote sensing. And again, just the definition here, use of cameras or other sensors mounted on aircraft or satellites to collect digital images of the Earth's surface. And so here's a couple of different ones. I'm going to tell you a couple of quick stories. So this is a map of the ocean floor. In 2014, an airplane, a passenger jet disappeared. Whoops, sorry about that. Disappeared over the Indian Ocean. Nobody knows what happened to it. And so they still don't. And so they sent all these ships out to try and locate where that plane might have landed. And so in doing so, when they were looking, they used some type of sonar, I guess. I should know that, but I don't. So they put this device on these ships, and they went through the ocean back and forth. And so they ended up mapping a lot of the terrain underneath the water that was unmapped before. All right, and so that's where this image came from. And so they were able to get, while they're looking for this plane, they were able to get this really cool imaging of the Earth's floor. This is Launchpad site in North Korea. And so this would be another example of remote sensing. This would be satellite imagery. This is ocean pollution. So we can get this bigger picture of what's going on. And this is a U-2 spy plane. And we actually still use these in the US. So these things fly at around 70,000, 75,000 feet. They have these really highly sophisticated cameras on them, and we would use these to fly over countries and still do. This one, well, not this one exactly, but in the late 1950s, I believe it was, or early 60s, we were spying on the Soviets, and we didn't think that they had missiles that would reach us. And so one of our jets was flying over the Soviet Union, and they shot it out of the sky, and a big political event ensued. So anyway, taking pictures like that would be remote sensing. Alrighty, here's some NASA satellite pictures in Cambodia. This is showing the effects of deforestation. So this is all the same area, and so you can kind of track 2001 up here all the way down to 2016, and you can kind of see, the progress of deforestation. Here's another remote sensing kind of. Obviously, the world isn't dark the entire time across the globe, and so NASA has taken these pictures and then they've put them all together to give us this image that you may or may not have seen. It's called The World at Night, and so you can see where all the lights are. That doesn't necessarily give us the whole story, but it gives us a story. All right, because clearly, is it showing the population would be the question, and the answer in some parts would be yes, and in some parts definitely not. The U.S., you can see the eastern half of the U.S. is highly populated, and so that explains the lights. Something like 80% of the population lives east of the Mississippi River, which is somewhere around in this area, and so this lack of light out here would just be a lack of people. All right, but when we get into other parts of the world, so there are people living in here. There's obviously a lot of people living in here, and so it's not quite, this is also a bit of a map of inequality because we want to be able to see, where people are living and does the light match up with that. And so to do that, they came up with a cartogram. And so I'm not sure if you can see, but there are grids, and each little box is a measure of population. And so when you see these boxes without any light in it, that indicates that there are people there, but no lights. And so it's a lack of access to resources. When you see these lines like this, or over here in the US, that means there's nobody in those boxes. And so those boxes have collapsed. This would be, mountain chains here. So you kind of get the idea. This is the Sahara Desert. It's so packed together. So anyway, this is a better map that shows us a better understanding of the levels of inequality. All right. Here's one of South and North Korea at night. Again, here's the dividing line. And, you know, lots of people live in North Korea. This is an interesting political map because it shows the difference between an authoritarian state, basically, and a free state. South Korea is a democracy. North Korea is obviously not. And so this is, if you have two different types of economic systems, capitalism down here and communism up here, all right? And so it's an interesting map to take a look at. Gives you some perspective. And finally, here's a map of, or a picture at night of Phoenix and Tucson. And this would be a remote sensing type thing. But anyway, all right. The other big thing that geographers use, and lots and lots and lots of other people use, is what they call GIS, Geographic Information System. And so this is when a bunch of data is fed into a computer, and then you can have that computer layer the type of information that you want. All right, obviously you can see Tucson has a GIS system, and so here was something that I just pulled up. And so I pulled up a map of Tucson and set a fixed area, all right? And so you can see the area here. And then I went into it, and you can play around with it, and you can just start clicking in different types of data that you want. And so I did property theft, and I set the dates up here. And so in the month of June, here is all the property crime that occurred in Tucson. And you know, these GIS systems, they can do incredible things because so much data is being collected in a lot of different ways, and you can just start clicking the different types of information you want and see where they fall spatially within an area. It is really, really awesome. And so you can see down here some of the uses: analysis of crime data, effects pollution, transportation, urban planning. There are a ton. You're going to have an assignment that shows you literally 1,000 uses for it. And so you kind of get the idea. GIS is a big deal. And I'll show you in class how to actually start creating some of the maps yourself. If you had a research project for another class, it would be kind of a neat thing to throw in. All right, here's just a couple of other GIS things. So let's say that you were doing city planning. This is proposed new tree trails. And so you could see, you know, here's some of your data. Well, that's the legend. And then here's population density. And so if you're trying to plan new trails or something, you would want to make it beneficial for more people. So you get the idea. So the last part of this unit is the difference between qualitative and quantitative data. All right. So let's get into that. So quantitative data is something that can be measured and recorded using numbers. All right, and so any type of strict numerical values that can be assigned, excuse me, are numerical or quantitative data. All right, and so here's just a few. This is a population pyramid, and so this is telling us the percentage of population broken down by age group. Over here, this is global mean temperature in centigrade, length of growing season. Again, all these are things that can be measured and numbered. All right, individual income in 2008. Again, percentages over here, and so you get the idea. So quantitative data is data that is numerical. It's easy to put into a GIS system because then computers can do their magic with it, and so it is more. It's an objective measure. All right, mostly objective. Leave it at that. Then we have qualitative data, and so qualitative data can be useful because if you look at quantitative data, it just gives you the raw numbers. And so qualitative data takes it kind of a step further and says what might be behind those numbers. And so this is where you get things like going out and doing an interview with somebody, looking at document archives, descriptions that people have given, visual observations. All right, so you go out and you actually look and see what's going on. It can't be necessarily put into numbers, but it can give you a much better picture of a much better understanding of what's behind the numbers. And so think about this one. Take a look at this example. How many think virtual school is just as effective as in-person school? And so I could give you some opinions, or I could give you, a list of choices and say highly effective, like on a scale of 1 to 10. And that could be some of our quantitative data. But if I said, tell me what you think about online school, and then we started to have a conversation, and I started to say, okay, I see you rated it an 8 or a 6 or a 2 or whatever it is. Tell me why you think that. And so that type of data gets more of, gives you a greater level of understanding of what's going on. All right, so perceptions, opinions, reasons for doing things, those are all part of the qualitative data. And you can see these are just some some ways to collect some qualitative data. All right, focus groups. If you have a business and you're launching a new product, a lot of times that product is introduced to a focus group, and then they just sit and talk, to the 20 people or whatever who just tried their product and say, hey, what do you like? What do you don't like? Things like that. All right, and so see if you can go through here. You can pause it and see if you can see if you can determine if this is qualitative or quantitative. So go ahead and pause it and try it. Pause it for 30 seconds and then come back. All right, so average temperature in July, that is a measurable thing, so that is a quantitative. I'm not going to write it out for all of them. Best restaurant in Tucson, that would be qualitative. Rainfall in inches, that's a numerical measure, so that's quantitative. Test score on your AP Human Geography test, that's numerical, so that's quantitative as well. The degree of difficulty on your AP Human Geography test, and so if I went and said, hey, what was hard about it, and then you could start to say, here's where the challenges were, or here's where it was really easy, that's more of a qualitative measure. If I just said, rate the difficulty on a scale of 1 to 10, that might be more of a quantitative measure. All right. The number of new COVID cases per day in Arizona, that would definitely be a quantitative measure. And then finally, whether Tucson should require everyone to wear a mask in public. If we go out and ask people, what do you think? That would be a qualitative measure. All right. So that's it for 1.2. 1.3 isn't as long. There's going to be 1 or 2 videos in here, but just stick with me. So the power of geographic data. So all this data that we collect, it's neat that we can collect it, but the more important thing is how do we use it? Because it can really, really lead to some really cool solutions, some new ideas, things like that. And so let's take a look. So this is a short unit, a short section to the unit. So this is using maps and data to figure out all these relationships. All right, so a couple of different types of geographic data. So you're going to see this word a lot, census data. And so a census is, in its strictest terms, in the way that you'll often hear it, is when the government goes out and counts everybody. And so in the U.S., every 10 years, by the Constitution says every 10 years, go out and count people, and that will help figure out which state gets which states get House members, how many House of Representatives members. And so you can read that all here. But and so besides just that, besides just counting people, census data can also include a whole host of different things. So it can include a lot of demographic data. And so different characteristics of the population, could be people's age, their education levels, gender, race, nationality, religion, language spoken, rates of illness. It could also have a lot of economic information. They could poll businesses. This is just any types of data sets that you could ask for. All right, and so census data is vast. If you go on the U.S. Census site, you can play around with it forever because they give you lots of different options and lots of different ways to break down data. All right, so that's one type. The other type that we definitely look at is satellite imagery, and excuse me, that's mostly done with that remote sensing, obviously satellites. All right, so here's an example of what the power of GIS. All right, so I typed in that I wanted to go to Los Angeles, and so you can see if you've seen this map on Google, this is obviously Google Maps. This is real-time data, and so whenever it was, I can't remember the time that I wanted to go, and so it just so you know, Google does track your phone, and so they're able to see where traffic is moving slowly and where traffic is flowing freely. And so by tracking people's phones. All right, they don't know it's you; it's an anonymous thing, but that's my understanding. But they can see, look, cars are moving much slower here, cars are stopped here. And so if you're coming in, they try and figure out what's the fastest route for you. And so you could come in and come up this road, but that would be a bad idea because they have all this data that this road is got a lot of traffic on it. Or we can bring in this one, and this seems to be one without a whole lot of traffic on it. And so this is real-time data being collected. It's dynamic data, but if you want to go somewhere, you can map it out, and Google will help you out because they're collecting all of this information. All of this information all the time. All right, give me just a second. I need to pause this for a bit. Be right back. All righty. I have a buddy who decided to join me. Sorry. Uh, So anyway, his name is Red. Getting back to the GIS data, obviously, and we'll look at a video here in just a second. This is, to be able to map. So this is an Ebola outbreak from 2015, and so to be able to map, where exactly. And so if hospitals would call in and say, hey, we've got this number of patients, and so if you're able to map exactly where those patients are, you know where to start to send resources. You can anticipate where future problems might exist. And so anyway, so this would be uh, a map kind of demonstrating that. So I do want to show you this quick video. This is how they've used GIS in COVID, getting ready for COVID here. And so it's some pretty powerful stuff. The other video I'm going to leave off, but do sit through this one. This is impressive stuff.
Hi, my name's Lauren Bennett. I am the product engineering lead for the spatial analysis and data science software development team at Esri. And I've also been coordinating our efforts around analysis and modeling and forecasting with our efforts to respond to COVID-19. We have been getting asked by a lot of you to help in integrating modeling and forecasting into your existing workflows. And we've been working really hard to help you in that area. And I want to share some of the work that we've been doing, which includes beginning to integrate some of the really widely used models that are out there to do this kind of work. We started with a toolbox, which right now has a tool that wraps the University of Pennsylvania's CHIME model, which is a pretty it's a really powerful model. It's being really widely used. It's a pretty traditional epidemiological model called an SIR model, which is about the susceptible, infected, and recovered population, bringing those three pieces of the puzzle together to accurately as possible forecast where we're going to have needs as far as hospital beds, ICU beds, and ventilators. And it's also really powerful because it also allows you to integrate some information about social distancing policies that are in place and how that might impact those projections. The most important piece of the puzzle here is data. If we've got the right data, we can make much more accurate projections. And so I know that many of you are already collecting and sharing information within the ArcGIS platform. We've all seen dashboards like this one, like the Johns Hopkins dashboard, this one from Florida, that is sharing information about cases, positive test results, and in this case, Florida is also sharing hospitalizations. And that's a really important piece of the SIR model and that CHIME model that we're going to take a look at. So I grabbed that data, and just for demo purposes, I'm using it for this example here. And this is the tool that we've built into ArcGIS. And really, this is about enabling you to take advantage of that really great science that's out there right inside of ArcGIS for the workflows that really require us to think spatially about what those results mean. So what we do is we point to our case data. And we know the underlying population. This is essentially that susceptible population part of the SIR. We also know the number that are currently hospitalized. Now, this is a really important piece because the model is going to take that the number of people hospitalized, as well as information we have about what the hospitalization rate is for this particular virus, and figure out from there the projected the estimated number of the population that's infected, since really our best bet at getting at that number infected is really about how many people are hospitalized. So then we can choose the number of days to project, we can choose a date to start, and then we have some options about how to fill out some of these parameters. So one of the ones that's really interesting is there's this social distancing. It's the reduction in social contact based on some of the policies that we're seeing, stay-at-home orders, shelter-in-place orders. And another really interesting thing that we're seeing a lot of is this great data that's out there about mobility and movement patterns. And there's a lot of opportunity to explore how we can scale our understanding of, okay, everybody's supposed to shelter in place, but everybody's not doing it either because they're not able to. Or because maybe there's some compliance issues. And so if we can analyze that spatial data and scale that social distancing number location by location based on compliance, we can incorporate that to get a better model. And then we can also have some constant parameters here, things about hospitalization rate, ICU rate, ventilated rate, how many days infectious. These are other things that we could do locally. So a hospitalization rate we know is going to change location by location based on the underlying population. And so while we have a constant here, we could fill that out as a field that we allow to vary spatially. Then finally, we can incorporate information about the number of beds, the number of ICU beds available, because that is going to feed into our understanding of capacity and help us do things like map capacity, understand what the demand's going to be when we're going to go over capacity, and use that information to allocate our resources and really plan to respond to the situation. So one of the outputs that we get here is the peak hospitalized census. So the larger the square here, the larger the number of people that is going to be hospitalized at that peak. And that's a really important variable for us to understand. That's essentially the demand. Now we can also visualize this in different ways. So for instance, we've got as well in that summary, a maximum number of beds over capacity. So knowing what the peak's going to be is important, but we also have a certain number of beds available. And we can see the number of beds over capacity that will be, and that's really going to help us do some more planning and allocate our resources. Now we can also, as part of this output, start to explore a little bit more about this model. We can start to see, for instance, this SIR chart. It gives us a sense of the susceptible population, the infected population, and then the infected population here, and then the recovered population. And so this is one of those kind of traditional outputs that are part of SIR models that's automatically created when you run it inside of ArcGIS. Now, we can also use the results of this kind of analysis to do a lot of different things, including make some comparisons of various what-if scenarios. In this case, we're looking at the difference in the curve of the disease based on different social distancing compliance. So in the map on the right here, we're looking at what if there was no social distancing? When would we peak and how high would that peak be? And then in the map on the left, we're looking at a 30% reduction in interaction, and we can see how high the peak goes and when that peak happens. And we can see this phenomenon that we are talking a lot about in the news, which is flattening the curve. We are flattening the curve, and we're able to see that because of social distancing, we get a peak that comes later and we get a peak that's much lower. And that's critical because one of the most important things to think about when responding to a crisis like this is how do we protect our healthcare system? How do we make sure that we are as close to capacity as possible so that we don't go so far over capacity that things get out of control. And so flattening that curve and lengthening the amount of time that people are becoming infected, but slowing it down so that hospitalizations don't all happen at the same time is really critical. And we can really see that happen based on those what if scenarios right inside of ArcGIS. And we can see also how that will change over time on the map and start to just see exactly when and where those overcapacities are going to happen. Now, in addition to those comparisons and understanding when and at what level will be overcapacity, we can go further because we're in our GIS, because we're integrating in with all of these other systems of information, the systems of record throughout our organization, we're able to then take this further, right? We can go on to do things like location allocation and start to think about if we understand how many beds over capacity will be in each of these locations, then we can start to plan where should we place surge sites so that we most effectively serve that demand. It's a really critical part of this process, being able to use the information, use the results of these models to really inform decisions. And those decisions are inherently spatial, and it's really important that we're able to make them in a really spatial way. So we are working really hard to support your efforts, the amazing work that you're already doing to collect this critical information, to share.
All right, so I'm going to stop that. But I hope you got the idea that these models that they talk about, and you heard the phrase ArcGIS. It's ARCGIS. That's a company that does this data collection, and so hopefully you can start to see the power of it. If you take a look at this, and I talked about the layering that GIS is able to do, and so if you can get the data, and the more access to data you have, the better your system. You start to get all of these different options that you can start to place on your map. And so again, it's a layering effect. Pick the data you want, layer it on your map, and see the effect that you get. All right. So here are a couple of other ways that the GIS is helpful. I'll just let you go. Take a look at those. Obviously, navigation, surveying, geology. I mean, there's just a ton. And there are majors in GIS, so if you think, you want to start nerding out on this stuff, I'll show you a website in class, ArcGIS website, and the stuff that you can do. And you will definitely, if you like the stuff, you'll go down a long rabbit hole trying to play with it. So it's pretty fun. But anyway, so I do have one more video. I think that's it. No, not quite. So go ahead and start this. This is 11 minutes. If this is a good video, and I encourage you to watch it, if you are pressed for time, then skip ahead just a bit to the
end. You've already voted in the next election and don't even know.
You know what? I'm not sure why it's off center, and that would be annoying for the whole video, so we'll just skip it. So she just shows how to map, how cities would use GIS. And she also talks at the end about, all of this stuff is driven by data. The more data, the better the model, but, is your data protected? Because can your data be used for things that you might not want it used for? And so I did pull this little thing up, the secret life of your data, what you need to know. And so here's how your data is being collected, maybe without you knowing it, maybe with you knowing it. So iPhones and Android phones, hidden trackers and apps share personal information. Alexa records everything. Credit cards can grab data about purchases, where you're shopping, the things that you're buying. TVs, once every few minutes, smart TVs beam out a snapshot of what's on your screen. I thought that was interesting. Cars can send data about how you're driving. Web browsers loading up a bunch of cookies. Cookies are, they track what's going on with some of your site usage. Browser extensions. You can, in California, get on. And so there's these agencies out there that collect all this data, and then they sell it to other people. All right. And so a lot of times when you sign up at a website, it'll give you this privacy notice that we all skip and just click the box and say, get me to where I want to be. But when we skip it, that's where they're saying, look, there's a pretty good chance we're going to be selling your data, and they'll tell you if they're going to sell it or not. And it's because that data is valuable. Companies pay a whole lot of money for this. Companies love to know if you're searching them on Google, and Google is happy to provide that information to those companies. If you've ever had like the targeted advertising, if you're signed into your Google account and you start searching for cameras, you'll notice that on some of your social media apps or whatever, you're going to start seeing more ads for cameras. All right, so that's the kind of data that's being collected. And so here's this last question I want to leave you with. Should the government, during COVID, should the government be able to access your phone data in terms of just your location, all right, not tapping into your phone, but access your location data anonymously to help to help look at the spread of COVID and help possibly fight the spread of COVID. You can see down here, this was from a couple weeks ago. Washington Post reported the U.S. government is in talks with Facebook, Google, and other tech companies using anonymous, right? They don't know it's you, but they still know there's somebody there. Anonymous location data to combat coronavirus. And so if we can track where everybody's going, it might make it easier to stop, to slow the spread for sure. And so the question is, should that be your own private information, or should the government have access to it? And so it brings up a really good question, privacy versus public safety. But anyway, that is it for this. Yep, because it's the next unit. And so again, make sure you filled out the terms that go along with that and submit those into Teams. And that's all I got. So we'll do some activities with this next class. All righty.